So the topic is last digit of a power. We will start it. This flashcard will summarize last digit of power concept in detail. Just go through the flashcard to get an idea. I will take each and every cases of this flashcard. Each and every case means when last digit is 0, 1, 2 up to 9. We have discussed about perfect squares, how to identify it. Here also that concept we are going to use, that the last digit is going to repeat. So I will just take this is a previous NET exam problem on this topic. June 2018 this question came. Like this 4 questions have came from the previous question papers if you analyze from this topic. And this is a topic that is asked in GATE exam also and many other competitive exams. This is a topic that will be there. So you are going to learn this topic by today's class. So what is the last digit of 2017 raised to 2017? Yeah, when you see the question, what is the main challenge? This is a 4-digit number, this is a 4-digit number in the power. Base even if we can manage, but power is 2017 means you have to multiply the number 2017 times with itself. So definitely multiplying and finding the last digit is not possible. Analyzing the last digit's property is the most important thing. So first of all, when you see this number, only the 7 matters.
Yeah, I am just starting with the very basic example. To do that previous NET exam problem, after understanding the basic idea, it will be very simple. So 71 plus 72 plus 73 plus 74 plus 75 plus 76. If it is asked last digit, first of all let me clarify, last digit and unit digit are same. If I use both the terminologies, don't get confused, both are the same. So the last digit of this you have to find. So definitely when you see the question itself, you will just do 1 plus 2 3, 3 plus 3 6, 6 plus 4 10, 10 plus 5 15, 15 plus 6 21. 21's last digit is 1, so you only need 1. That means the 7 does not matter, na? Not only in addition, for multiplication also that is the case. For example, this question, if it was multiplication in between, what will happen? 71 into 72 into 73 into 74 into 75 into 76, you don't have to multiply. You just have to multiply the last digits, because last digits multiplication product, that last digit itself will be the final answer for sure, because we know that is how multiplication works. 1 into 2 2 into 3 6, 6 into 4 24. 24 also is not needed. 24's last digit 4 is enough. That 4 multiplied with 5 is 20. 20 means 0 ending. 0 into 6 is 0 again. So the final answer is 0, last digit of this. So you understood that for finding the last digit only matters. Whether it is multiplication, whether it is addition, whether it is power also, this is going to be the same. That means even if it was 271, 272, 273, 274, 275, 276, still the answer will be 0. Yeah. One more thing, as a matter of fact, here to find 0 you don't have to even do this much. The last digit with 2, last digit 5, these two things are enough to say that 2 into 5 0. In previous chapter we discussed this concept. 2 into 5 will combine to make a 0. So definitely the product is having a 0 means final value also the last digit will be 0 only, because 0 into something is going to be 0 only, na? That is why this is 0. Now what if it is a power like this? That is how normally question comes, like in a power or a factorial form, or like sum of 2 powers or a product of a power plus a sum. So this way I will try to categorize it into 3 types according to the last digit's nature. Last digit who is having cyclicity 1, last digit who is having cyclicity 2, last digit who is having cyclicity 4. Now what is cyclicity? That I will explain. So here cyclicity means in the last digits how many elements are there in the cycle of last digits. For example, 121 raised to 81 is 121 into 121 into 121 into 121 81 times. There also I told you only last digit matters. 1 into 1 is 1. Once you got a 1, 1 into 1 is again 1, again 1. So you understood that in the cycle only one element is there, and that element is 1. In the cycle one element only is there, that is why we say that cyclicity is 1. So if the number base is ending in 1, its cyclicity is 1, so any power will also end in 1. That means last digit will be only 1. Now cyclicity 1 is for which all last digits? That is what we are discussing. For 0, 1, 5, 6, all these 4 numbers, cyclicity it is 1. That means 30 raised to 91 can be only 0 ending. This is 1 ending. This is 5 ending. This is 6 ending. Why? Because 0 into 0 into 0 into 0, 91 times or 1000 times or 10,000 times, it is going to be 0. Na? Because in the power cycle of 0, only one element is there. That is 0. And 1 we already discussed. 5. 35 into 35 into 35 into 35 into 91 times is this. 35 into 35 means 5 into 5 is 5. 25, 5 ending. That 5 into 5 again going to be 5. So how many times you multiply, that is all going to give you 5 only. So whatever power it is, last digit is going to be 5 only. Now 36, think about 36. 36 last digit is 6. 6 into 6 into 6 into 6, 91 times. 36 we are not considering the 30 part because that does not matter for last digit. Now 6 into 6, 36, last digit is 6. That 6 into 6 again 36, last digit 6 and so on. That is why cyclicity 1 elements are last digits 1, 0, 1, 5, 6. In this flashcard also you can see the same. Look at the yellow marked region. 0, 1, 5, 6. These 4 numbers, cyclicity is 1. That means all elements will be the same last digit itself. So if the cyclicity is 1, then the question is very simple. But normally they try not to give cyclicity 1 examples because then you can do the question so simply. That is why normally they give cyclicity 2 element or cyclicity 4 elements. Okay, I think all of you understood cyclicity 1 elements, these 4, 0, 1, 5, 6. Now I think you get more clarity on what is this flashcard all about. Now cyclicity 2 elements. Cyclicity 2 elements, there are 2 in number. 4 ending numbers, 9 ending numbers have cyclicity 2. Cyclicity 2 means only 2 distinct last digits are possible. That will just repeat like a cycle. Repeat like a cycle means third element, fifth element, seventh element, etc. in the will have the same last digit. Second, fourth, sixth, eighth all have the same last digit. Okay, that we will explain now. Cyclicity 1 you understood, I guess. This is a generalization of cyclicity 1. Whatever digit comes before the last digit, that does not matter. That is why I am denoting all those values by m. M can be anything. It can be 12, it can be 323, 3230 raised to whatever x. That is why power I am generalizing as x. Whatever x. For example, if it is 1001, still the answer will be only 0. Now here if the m is 1, 2, 3, 4, but if the last digit is 1, this m does not matter. That is what I am saying. And the x also does not matter. Let the x be 432. Still the last digit will be only 1. Same way here. So that m denotes whatever digits comes before the last digit, that does not matter. And the x denotes whatever power comes, that does not matter if the cyclicity is 1. Now if the cyclicity is 2, it is not that simple. You have to take 2 cases possible. For example, I am starting with the example of 34 raised to 91. 34 raised to 91, when you see itself, I told you this 3 does not matter because that is the m part. Only the last digit matters, 4. Now you have to understand the power cycle of 4. How 4 behave in terms of power last digit. 4 raised to 1 is 4. 4 raised to 91 means what? 4 into 4 into 4 into 4 into 91 times. 4 into 4 is what? 16. 16's last digit 6 only matters. 6 into 4 is what? 24. 24's last digit 4 only matters. 4 into 4, 16. Last digit 6 only matters. Now you understood that that is going to give you 4, 6, 4, 6, 4, 6 repeated. 4 raised to 1 is 4 ending. 4 raised to 2 is 6 ending. 4 raised to 3 is 4 ending. 4 raised to 6, 4 is 6 ending, and so on. That is how you derive that if the last digit is 4, its power cycle will be 4646. Power cycle have only 2 elements. That is why we are calling that cyclicity is 2 here. Now, as a shortcut I can say, If there is only two elements in the power cycle, what you only have to check is whether the power is odd or even. If the power is odd, first element will be the answer. If the power is even, second element will be the answer. Because power cycle is like this, 4 6 4 6 4 6. This is for odd cases, this is for even cases. Odd and even depending upon the power's odd and even nature. That is what we are discussing. I think this is also clear. So can you just try this example? I will just make a random value 1 2 3 4 raised to 1 2 3 5. 1 2 3 4 raised to 1 2 3 5. All of you find it. Less than 10 seconds you can finish it. I think all of you got the answer. 1 2 3 4 means 1 2 3 does not matter. 4 raised to 1 2 3 5. Now 1 2 3 5 is odd or even. 4 raised to odd number. Odd number means 4 will be the answer. Last digit is what we are discussing. If it was 1 2 3 4 raised to 1 2 3 4, then it is even power. Then the answer will be 6. Last digit of that. So cyclicity to 4 is an example. 9 is also another example. 9. Look at these two examples. 39 raised to 91, 39 raised to 92. 39 raised to 91 means what? 39 into 39 into 39 into 91 times. Again, we only are concerned about the last digit. So 9 into 9 into 9, 91 times. Sorry, 91 times. 9 into 9, 81. 81's last digit is 1. 1 into 9, 9. 9 into 9, again 81, 1. Then 1 into 9, again 9. Look at this, 9 1 9 1 9 1. It repeats. So we understood that for 9 also there are only two elements in the power cycle. So power cycle 2 elements is called cyclicity 2. That is for 4 ending number and 9 ending number. 4 ending number, 4 and 6 are the two things. 9 ending number, 9 and 1 are the two things. Let me give you an example. If it is like 6 7 8 9 raised to 1 2 3 4. What will be the value? 6 7 8 9 raised to 1 2 3 4. What is the last digit? Only this 9 matters. 9 raised to even power. 9 raised to even power means second element in the power cycle 1. If it was 6 7 8 9 raised to 1 2 3 4 5, that is an odd power. 5 ending number, odd power. 9 raised to odd power, 9 will be the answer. I think that is also clear, and that is what you are seeing in the power cycle here. That means in the flashcard here you can see 4 6 4 6 4 6 repeated, 9 1 9 1 9 1 repeated. That is why it is called cyclicity 2. So these are the two simple ways they can ask the question: when the cyclicity is 1, when the cyclicity is 2. Remember which all values have the cyclicity 1 and cyclicity 2. By practice that will automatically come. 0 1 5 6 have cyclicity 1, 4 and 9 have cyclicity 2. All other remaining elements 2 3 7 8 have cyclicity 4. That means there are only 3 varieties of question that can come according to the cyclicity. 1 cyclicity case, 2 cyclicity case, 4 cyclicity case. 4 cyclicity case is what we are going to discuss in detail, because majority of the time they have asked 4 cyclicity case. In this flashcard, the right hand side you can see an example that I have elaborated. We will learn the concept and then we will go for the shortcut for it. So 4 cyclicity case, as I already told, 2 ending number, 3 ending number, 7 ending number, 8 ending number have this property. Whatever before it does not matter, only the last digit matters. Last digit and its power only matters when you are finding the last digit of a power. So we will take one by one. 32 raised to 91. Those of you got the concept, you can try yourself. 32 raised to 91 is what I am explaining first. So I already told you cyclicity 4, but let's understand what is the meaning of cyclicity 4. First of all, 32 raised to 91 means 32 into 32 into 32 into 91 times. That is 2 into 2 into 2, 91 times. That only matters here. 2 into 2, 4. Again 32's. 4 into 2, 8. Again 32, 2 only I am taking. 8 into 2, 16. Again 32. 6 into 2, 12, that is 2. So it started with 2. 2 4 8 6 it happens. After that it again started with 2. Again that 2 into 2, again 4. Look at this. This 2 4 8 6 pattern started repeating. That means a cycle started repeating. So we understood that cyclicity for the 4 elements in the case of 2 are 2, 4, 8, 6. If you ask me whether you have to by heart it, I will say don't by heart it. Practice much questions, automatically it will come in your head. Otherwise, if it is not coming in your head, just think 2 into 2, 4 into 2, 8 into 2, 6 into 2, again 2. That is how you decide 2, 4, 8, 6 are the elements in the power cycle. So we understood that these are the elements in the power cycle. Now, as 4 varieties are there, it is not as easy as odd and even power, because there are 4 possibilities. So how to determine the possibility, that is what I am teaching you. First I will tell the concept. 2 raised to 4 will be ending in 2486, the last element in the power cycle. Last element. 2, 4, 8, 6 are the elements in the power cycle. Na? So 2 raised to 4 ends in 6. Next 2 raised to 8 also ends in 6. 2 raised to 12 also ends in 6. That means if the power is a multiple of 4, it ends in 6. Or it ends in the last element in the power cycle. If the power was a multiple of 4. From multiple of 4, we can again start the cycle. After that multiple of 4, again, if it is multiple of 4 plus 1, if the power is multiple of 4 plus 1, first element will be the answer. In the power cycle, first element. If it is multiple of 4 plus 2, second element will be the answer. If it is multiple of 4 plus 3, third element will be the answer. This 91 you have to consider and see whether 91 is what kind of number. Whether it is multiple of 4? No. 88 is the nearest multiple of 4. 88 plus 3 is 91. So you understood that this is multiple of 4 plus 3. Why this multiple of 4 concepts comes? Because 4 elements in the power cycle, after 4 elements this is repeating. After every power which is a multiple of 4, after that the power starts, last digit of the power starts repeating. 91 is 88 plus 3, that is why this 3 only matters, this 88 does not matter. This is the third type. Third type means third element. That means 32 raised to 91. The answer is third element in the power cycle. 2486 is the power cycle. Third element is 8. So the answer is 8. That is the idea. I will summarize what I just told. If the last digit of the base is 2, whatever before that does not matter. That is why I am writing it just like an M. Now the power can have 4 varieties. Start from here. Multiple of 4 is the 4th variety. That means power being multiple of 4. For example, if it was 32 raised to 92, answer would be clearly 6. 32 raised to 92. Now if it is 32 raised to 93, that is multiple of 4 plus 1, because 92 is a multiple of 4. 93 is 1 more than that. Then the answer will be 2. I will use a smaller thickened pen. So if it is 32 raised to 94, 92 is multiple of 4, 94 is 2 more than that. 2 more than that means second element. If it is 3 more than that, 95, then third element, 8 will be the answer. 95 is 8, 91 is also 8, 87 is 8. It is like a cycle. Are you getting the point? I hope all of you are clear about this. So this is, or in other words, this is a shortcut I can tell you. When you see a question from this topic, first you have to decide whether the cyclicity is 1, 2 or 4. Most of the time they will ask cyclicity 4 case. So you decided cyclicity is 4. Write down the cyclicity of the last digit 2. Find it. 2, 4, 8, 6 is the cyclicity. If you already remember it, directly write it, or don't write it also. Think it in the mind. Keep it in the mind. 2, 4, 8, 6 are the 4 elements. Now only consider the last digit. Remaining things does not matter. Last digit's power cycle we already written. Now think only about the power. Power divided by 4. What is the remainder? Mathematically that is called mod 4. I don't know whether you have used that terminology. Mod 4 means 91 by 4. What is the remainder? If you haven't used that terminology, don't worry about it. 91 divided by 4, find the remainder. That is the meaning of this term. 91 by 4, remainder is 3. If remainder is 3, third element will be the answer. If the remainder is 2, second element. If the remainder is 1, first element. Remainder is 4 does not comes, because when you divide a number by 4, maximum remainder you can get is 4 minus 1, 3. Because when you divide 4 is the remainder, means you can divide that 4 again by 4 now. So remainder 0, that is called multiple of 4. Then fourth element will be the answer. Okay, I think you have got the idea with this. Remainder itself is same as multiple of 4 plus 1. This 1 is called remainder. This is remainder. This is remainder here. Here the remainder is 0. So if you think in terms of remainder, if you think in terms of multiple, both are okay. If your mathematical skill is good, I will say don't take remainder or anything. Just think nearest multiple, how much more it is. So let's see. 33 raised to 92. If you have understood it, try it yourself. 33 raised to 92. That means when the last digit is 3, what happens? This 3 does not matter. 3 raised to 92. 3 raised to 92 means 3's power cycle you have to analyze. 3's power cycle is 3. 3 into 3, 9 into 3, 27 into 3, 81. 81 ending in 1. After 1, 1 into 3 again 3. That cycle repeats. So 3971 is the power cycle. Now the power you have to take 92. As the 92 is a multiple of 4, you choose the last digit. Last value in the power cycle 1. So if it was 33 raised to 93, it will be, the answer will be 3, because 93 is 1 more than a multiple of 4. That is 3. If it was 33, so the answer will be 3 here. If it is 33 raised to 94, it is 2 more than 92. 2 more than a multiple of 4. So second element. 2 more than, that is why second element in the power cycle, so 9. So if it is 33 raised to 95, 3 more than last digit, that means third element, 7 will be the answer. If it is 33 raised to 96, again 1 will be the answer, because 96 is a multiple of 4, just like 33 raised to 92. 33 raised to 92 was 1, same way 33 raised to 96 also is 1. So I think that is clear. So summarizing, for last digit 3, 4 elements are there. When 1 will be the answer, fourth element will be the answer if it is a multiple of 4. If it is a multiple of 4 plus 1, first element. If it is multiple of 4 plus 2, second element. If it is multiple of 4 plus 3, third element. Multiple of 4 plus 1 or remainder 1, both are same. Remainder 2 when divided by 4 is same as multiple of 4 plus 2. Remainder 3 when divided by 4 is same as multiple of 4 plus 3. Remainder 0 is called multiple of 4. So you understood cyclicity for the case of M3 kind of number, M3 raised to X kind of numbers. Now if it is 7 or 8, so 7 we will take first, after that we will take 8. 37 raised to 93, 7's power cycle you have to understand. CSIR have asked 2 times regarding 7 itself. So 7931 is the power cycle of 7. You can try yourself. 7 raised to 1 is 7. 7 raised to 2 is 7 into 7, 9. 9 into 7 is 3 ending. Then 3 into 7 is 1 ending. 1 into 7 again starts 7. You can write it down and check. 7 raised to 1, 7 ending. 7 raised to 2, 49, 9 ending. 7 raised to 3, 343, 3 ending. 7 raised to 4 will be 1 ending. 7 raised to 5 again going to be 7. So this is the power cycle. Once you obtain the power cycle, now you just have to observe the property of the last digit. Here that last digit is 93 means 8 ending we will discuss later. Property is 93 means 93 is what kind of number? It is multiple of 4 plus 1 kind of number, because 92 is a multiple of 4, so 93 is 1 more than that. 1 more than that means the power cycle you just have to take the first element, 7 in the power cycle. 7931 is the power cycle, so the first element 7 will be the answer for this question. We can summarize this kind of questions also like this. If it is multiple of 4 plus 1, first element, plus 2, second element. For example, if the question was 37 raised to 94. 94 is 2 more than 92. 2 more than a multiple of 4. Or the remainder is 2 when 94 divides by 4. So second element. If it is, so 9 will be the answer. If it is 37 raised to 95,
3 more than the last, 3 more than a multiple of 4. So third element in the power cycle, so 3 will be the answer. If it is 37 raised to 96, 4 more than multiple of 4, that means a multiple of 4 itself. That means 1, last element in the power cycle, 1. So I think you all understood how to determine last digit of a power. And now the last case is when the last digit is 8. That is also cyclicity 4 case itself. 8 into 8, 64, last digit is 4. 4 into 8, that 4 into 8 again. 32, last digit is 2. 2 into 8, 6, last digit. Then 6 into 8 is going to be again 8. You can try yourself. 8 raised to 1, 8 raised to 2, 8 raised to 3, 8 raised to 4. Last digit you check. After 8 raised to 4, the cycle is repeating. That is why 4 elements in the power cycle. So 8, 4, 2, 6 are the 4 elements. Now the same technique we use for the last 3 cases. Just think about the power 94. 94 is 92 plus 2. 92 is a multiple of 4 plus 2. Plus 2 means second element. 4 is the answer for this question. So 4 is the answer for this question. Summarizing, if it is multiple of 4 plus 2, second element, that is 4. If it is multiple of 4 plus 1, first element. Multiple of 4 plus 3, third element. Multiple of 4, fourth element. That means 38 raised to 93 will be giving you this answer. 38 raised to 94 will give you this answer. 38 raised to 95 will give you third answer. 38 raised to 96 will give you fourth answer. So that are the 4 cases when the last digit is 8. And that is summarized in this flashcard again. Look at this. Multiplicity, cyclicity 4 case, these 4 things. The white marked region you can see. And the procedure I told now, the step-by-step procedure I have given here. In case you have forgotten this any time for CSIR-NET or any other exams you are preparing, this flashcard will remind you what we have learned today. So I think you have understood this. Now we can do the questions which came from this topic in CSIR-NET exam. This is the first question. Now the questions will hardly take 30 seconds. All of you try it. The first question I showed you before also. I think you have tried already. I will start the explanation due to lack of time. 2017 raised to 2017 is the question, means this 201 does not matter. 7 raised to 2017 only matters. Now think about the 7s. 7's power cycle you have to derive or you have to learn. 7931 is the power cycle of 7. Now how to determine which among these 4 are the answer, because look at the 4 options. All the 4 options are giving 7931 itself. That is determined by the nature of the power. 2017. 2017 is 2016 plus 1. 2000 is a multiple of 4. So 2016 is also a multiple of 4. Otherwise use the test of divisibility technique I taught you. Last 2 digits is 16, means 16 is a multiple of 4. So 2016 also will be a multiple of 4. 2016 is a multiple of 4 means 2017 is 1 more than that. That means the remainder is 1. Remainder is 1 means first element is the answer. So option C is the answer here. Very simple question if you know this theory. If you don't know this theory, this is going to be a very confusing question also. So now let's go for another question. In June 2017 question paper this came, but this is little different. Here also the last digit concept itself should be used, but how it should be used, that can be only understood by carefully analyzing the question. So I will give you 30 seconds, all of you try this. It is not directly asking what is the last digit of the power, it is asking the remainder when this power is divided by 5. So you have to know some property. When you divide something by 5, what all can be the remainder. Okay, so I will start explaining. First of all, I will find the last digit of this power and I will tell you why we need that. First, I am just taking the last digit of this power, that you are very confident. I think it is a power cycle of 3. Power cycle of 3 we learned 3971. 3 into 3, 9 into 3, 27 into 3, 81. 1 last digit, 1 into 3 again 3. And 256 is a multiple of 4. So the technique we use, fourth type it will be, because it is a multiple of 4. That means we understood that the last digit of this power is going to be 1. Or I will represent the number like some m into m1, not m into m1. m can be any digit, m can be anything. It can be 1 2 3 4 5 1 6 6, we don't know what, because 3 raised to 256 is going to be a very big number. How many digits itself to estimate, it will take time. So anyway, whatever m, the last digit is going to be 1 na? Now this number divided by 5, what will be the remainder? A 1 ending number divided by 5, definitely the remainder can be 1 only na? That is a property of division by 5. When you divide a 1 ending number by 5, the remainder is going to be 1 only. For example, if it is 31 by 5, what is the remainder? Remainder is going to be 1 only. 41 by 5, remainder is going to be 1 only. 1001 by 5, remainder is going to be 1 only. That is enough to say that option A is the answer. Once you got the last digit of the power, you can easily say, because 5, if it was not 5, I totally agree, it will be a very difficult question. That is why they have given division by 5 itself. They are checking whether you know last digit of a power concept, also whether you know the basic idea. When you divide a number by 5, what all are the possible last digits. Yeah, I agree that if the last digit that you are getting for the power is above 5, then when you divide by 5, you are not going to get the same value. You are going to get the last digit minus 5. For example, if it was, you are getting m7, then m7 by 5 is not 7, because when you divide something by 5, you can never get a remainder 5 or more than 5. There the remainder is 2. 7 minus 5, 2. That is not needed in this question. In this question, only thing needed is, when you get that the last digit is 1, a number ending in 1 divided by 5, remainder can only be 5. Remainder can only be the last digit of the number 1 itself. That is why option A is the answer. So this was the June 2017 question. One more question from the same topic in June 2014 NET exam. This was asked, and this was simpler than the last two questions, because here you don't have to find the last digit. Here you only have to find how many numbers will be there with this last digit 3. That you can do only by checking what is the cyclicity, whether it is cyclicity 1, cyclicity 2 or cyclicity 4. That how you can find. This is 17 raised to 1 up to 17 raised to 300. That is 7 raised to something na. 7's power cycle, you know that 7, 9, 3, 1, 4 elements are there. What are the element does not matter. 4 elements are there in the power cycle. 4 elements are there in the power cycle means after every 4 elements, in every 4 powers, there will be a last digit 3 for sure, because 3 is there in 3 is one of the last digits. So in every multiple of 4 powers, one last digit 3 will come. 17 raised to 1 up to 17 raised to 300 means 300 numbers are there na. In every 4 numbers, one time last digit 3 is coming means in 300 numbers, 300 by 4, 75 times it will come. So option B is the answer. Read the question very carefully. Question is not asking what is the last digit. How many of these numbers, 17 raised to 1 up to 17 raised to 300, end in 3? In every 4 numbers, one number ends in 3 because 17's power cycle have 4 elements. If it was instead of 17, if it was 14 means then 3 will not be there. If it was 14 raised to 1, 14 raised to 2 up to 14 raised to 300, and if the question was how many times the last digit 4 is coming, then it will not be 75 times, it will be 150 times, because in every 2 elements, one element is ending in 4. So if the cyclicity is 2, you have to divide by 2. Here the cyclicity is 4, that is why you are dividing 300 by 4. That is why I told, understand the concept clearly, so that whatever way they ask, you can easily do the question. This is also clear, I guess, and this is the 4th question asked from the same topic. Very straightforward question now, I guess. June 2013 NET exam, this was asked. What is the last digit of 7 raised to 73? 7 raised to 73, 7's power cycle, 7, 9, 3, 1. Now the power 73, what kind of number that is? Either 73 by 4, take the remainder. 72 is a multiple of 4. So 73 is 1 more than multiple of 4. Remainder is 1. 1 more than multiple of 4 means first type will be the answer. First type means first element in the power cycle will be the answer, option A. As I already explained the theory for 2017 raised to 2017 question, this is easy I guess. We don't want more explanation I guess. So option A will be the answer. Same like 2017 raised to 2017, and the answer is also same. Because that power 2017 is also a multiple of 4 plus 1. This power 73 is also a multiple of 4 plus 1, and the bases are also same. So this is how last digit of a power concept questions came in CSIR-NET. 4 different exams this came, all the 4 questions we have discussed. And this is how they can improvise the question. I'm not saying in CSIR it will come, but in other exams these way also last digit concepts were asked. This is more simple than the previous one. What is the last digit of 1 factorial plus 2 factorial plus up to 2020 factorial? 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, last digit is 6, plus 4 factorial is 24, last digit is 4. Now you may be thinking this much big factorial, how we are going to find? But understand, from 5 factorial onwards, all the factorials last digit will be 0 only. Why? Because what is factorial concept? 5 factorial is 120. Once you understood 5 factorial ends in 0, 6 factorial is 6 into 5 factorial. Na? 6 into 120. 6 into 120 means 0 ending number multiplied with anything, you will get a 0 ending answer only. Now 7 factorial is 7 multiplied with this. That also will give you 0 only. So understand, for factorial concept, 5 factorial and above, all of them ends in 0. That means even if the question gives you how many factorials in the series, you only have to find 1 plus 2 plus 3 plus 4, 1 plus 2 plus 6 plus 24, that is 4 ending. This last digit only we need. That is 1 factorial, 2 factorial, 3 factorial and 4 factorials last digit. 1 plus 2, 3, 3 plus 6, 9, 9 plus 4, 13. 13, 3 is the last digit. So option B is the answer. Another question in the same pattern, do this. This is more easier than the previous one. What is the last digit of 3 factorial plus 4 factorial plus up to 4333 factorial? Here from 5 factorial to 4033 factorial, all of them last digit is going to be 0 only. So the only thing matters is 3 factorial, which is 6, 4 factorial, which is 24, last digit is 4. 6 plus 4 is 0, 0 ending, that is why option D is the answer. The remaining things are 0. Now the combination of powers can come. Combination of powers, try this. 29 raised to 391 plus 24 raised to 392. 9 and 4, they are cyclicity 2 type of numbers. 29 raised to 391 means 9 raised to an odd power. 9 raised to an odd power means first type. First type in 9 is 9. 4 raised to 392. 4 raised to an even power. 4 raised to even power means second type. 4, 6, 4, 6, 4, 6, so 6. Now you have to sum it up. So sum the last digits. For 9 plus 6, 15. Last digit is 5. So option D is the answer. Very straightforward question. Factorial sum, it is very simple if you understood the properties of factorial very well. 1 factorial is what? Is 1 now. 2 factorial is 2 into 1, 2. 3 factorial is 3 into 2 into 1, 6. 4 factorial is 4 into 3 into 2 into 1, 24. 5 factorial is 5 into 5, 4 into 3 into 2 into 1, 120. That means 5 factorial ends in 0. Factorial property, you know, n factorial is n into n minus 1 factorial. That means 6 factorial onwards, all the factorials last digit will be 0. 7 factorial last digit will be 0 because it started giving a 0. A number ending in 0 multiplied by anything else, you will get a 0 only. And 6 factorial is nothing but 6 into 5 factorial. 5 factorial is 0 ending, so 6 into 0 ending number will give you 0 only. And that 0 ending number into 7 will give you 0 only. That 0 ending number into 8 will give you only 0. So all the factorials 5 or above factorial will be 0 ending only. That is why 1 factorial last digit 1, 2 factorial last digit 2, 3 factorial last digit 6, 4 factorial last digit 24 last digit 4. Plus all the remaining are 0. That is why only these 4 are supposed to be added. 1 plus 2, 3 plus 6, 9 plus 4, 13. That is why option D, 13's last digit 3, option B is the answer. And the next question, same way. 3 factorial is the starting, 3 factorial is ending in 6, 4 factorial ends in 4. All other factorials above that is 0 ending. That is why 6 plus 4, 10. 10 ends in 0. That is why the last digit is 0. Option D is the answer. Now the second homework question, this one, 2 raised to 296. This is 2 raised to 296 means 1 raised to 296 ends in 1. 2 raised to 296. All are multiples of 4. All powers are multiples of 4. So fourth element in the power cycle is what we want. First of all, 1 ending, 5 ending, 6 ending number, you don't have to do any work. Just write that last digit itself. 4 ending also it is easy. 4 raised to even power, it is 6. Second type. Now the only two things you have to work a little hard is 2 and 3 because they have 4 elements in the power cycle. You know that 2, 4, 8, 6 are the 4 elements in the power cycle. 6 is the fourth element. That is why this value 6 is the last digit. And for 3's power cycle, 3971 are the 4 elements. 296 is a multiple of 4. Fourth element is 1. So 1 is here. So we understood 1 plus 6 plus 1 plus 6 plus 5 plus 6 will be the final answer's last digit. That last digit will be the final answer's last digit. 1 plus 6 7 plus 1 8 plus 4 6 14, 14 plus 5 19, 19 plus 6 25, 25 ends in 5. So option D is the answer. Second homework question, 6 raised to 296. Here also it is simple because power is very simple. Power is simple means 6 raised to 296 ends in 6. 7 raised to 296 ends in 7931. 7931 means 1. 6 into 1. Yeah, the power cycle you have to get practice with. 898426. So 6 is the last fourth digit. All are power last fourth one. 919191. So 1. So this you have to multiply. 6 into 1 6 plus 6 into 1 6. 6 plus 6 12. 12 ends in 2. That is why option B is the answer. I think it is clear now. All these are power ending power with multiple of 4. 9 raised to even number, 1 is the answer. All other 3 you have to derive the last digit.